So in the last video we talked about the product and quotient rule for radicals. Today we're going to talk about breaking down radicals as much as you can. Before we do, I wanted to do a quick little review about what radicals even mean. So when we have this right here, remember if there's no index written, it's understood to be a 2. So if there's a 2 there, that means what times itself, like 2 times, gives you that number. In this case, you should know that it's 6 because 6 times 6 gives you 36. It's 2 of them. 6 times 6 is 36. With cube roots, so if you have a little 3 index here, instead of having it 2 times, you're just going to have it 3 times. So what times itself 3 times would give you 8? And the answer in that case would be 2. Because 2 times 2 times 2, 3 times gives you 8. With 27, the cube root of 27 is 3. That's because 3 times 3 times 3 gives you 27. So these are 2 cube roots you probably want to have memorized, just kind of off the top of your head. The cube root of 8 is 2, the cube root of 27 is 3. All right, so with radicals, sometimes they evaluate to a whole number, but sometimes they don't. For example, let's do the square root of 20. The square root of 20 does not square root evenly because 16 square roots evenly, that's a little too low, and 25 square roots evenly, but that's a little too high. So 20 is somewhere in between there. And we could guess, or we could put it in the calculator and get out a decimal, but sometimes you just want to simplify, not put it in the calculator, just simplify. And with radicals, it's considered more simplified if you have some of it escape the radical. Basically, this is like,
Sherry, District, come to the front office. Sherry, District, come to the front office.
it's like this is jail or something, and you want to help some of it, if not all of it, escape the radical. So it's more simplified if you can get some stuff out front, out of the radical. So 20 doesn't square root evenly, but what we could do is split 20 into maybe something that does square root evenly. For example, the things that square root evenly would be 1, 4, 9, 16, 25, 36, and so on, because this is 1 squared, 2 squared, 3 squared, 4 squared, and so on. So keep these in the back of your mind. Which of these divides into 20? The answer we're looking for would be 4. Basically, we could split 20 into 4 and 5, or 4 times 5, because 4 times 5 is 20. So all I did was replace 20 with 4 times 5. The reason this is helpful is because now I can use the product rule, which says I can split up this multiplication into the square root of 4 times the square root of 5. And the reason that's helpful is because I can square root the 4. It's 2. I can't square root the 5, but that's okay because at least I got part of it out. So I can't square root the 5 and I can't break it down any further. So that's my final simplified answer. Since I have less under the radical, it's more simplified. If you were to type this into your calculator and this into your calculator, you should get the same decimal number. So ultimately, the goal is, if you can't square root something evenly, break it down into something that will. Here's another example. Let's do 252. Square root of 252. All right. You may try to square root it, but it doesn't work. So I'm going to break it into something that does square root evenly. I have no idea what divides evenly into 252, so I'm going to get my calculator and start trying to divide it by some of these numbers. And you really want the highest one possible. So like, does 252 divide by 4? It actually does, but let's maybe try some bigger ones to see if a bigger one will work. Does 252 divide by 9? It actually does divide by 9 too. 4 times 9 is 36, so it probably divides by 36. Let's try that. 252 divided by 36, this is what I typed in my calculator. 252 divided by 36 is 7. That means I could split 252 into 36 times 7 as separate radicals. The reason I did that is because I can square root 36. It's just 6. The square root of 7 will just have to hang out in there. And there we go. It's okay if you don't pick the biggest thing right off the bat. So for example, if I split 252 into, like, I found that it divides by 4 and I got 63 left over. So 4 times 63 gives me 252. That's good because the square root of 4 is 2, but it's possible that this keeps breaking down. So I do want to check and see, does 63 divide by any of these? And it does, it divides by 9. 63 and 9, that leaves you with 7. And the 2 is still there, so don't lose the 2. The square root of 9 is a 3, and 2 times 3 is 6. All of this is being multiplied. Don't add it, it's all multiplication here. So notice we actually got the same thing that we got before. It took a few extra steps, which is why I try to use the biggest thing right off the bat, but we still got to the same answer, so that's okay if you have to do it a couple times. All right, let's add some variables in here. Let's do the square root of x to the 4th. Square root of x to the 4th, like any square root, is we're trying to figure out what times itself, like 2 times, will give us x to the 4th. It can't just be x, because x times x is x squared. So what if we did x squared times x squared? That would give me x to the 4th. So that's the answer here. It's x squared. Kind of a shortcut is take the whatever's here and divide it by 2, and it gives you the exponent you need. For example, let's do the square root of x to the 6th. Again, what times itself will give me x to the 6th? You may just need to play around with some things, or you could think about 6 divided by 2, but the answer is x cubed, because x cubed times x cubed gives you x to the 6th. All right, let's try something like this. What happens if I want to square root x cubed? If you'll notice, 3 doesn't divide by 2 evenly, or I can't really come up with anything times itself that would give me x cubed. So this is kind of like when we tried to square root 20, like it doesn't square root evenly, but if I could help some of it break out from that radical, then it would be at least more simplified. So what we're going to do is, just like before, split this into 2 separate pieces that maybe you could square root part of it. Keep in mind, x cubed is x times x times x. It's 3 of them. So how much of this could I actually square root? Well, I could square root x squared. Like if I made this x squared, I could square root that, and it would leave an extra x, but that's okay. So what I'm going to do is split x cubed into x squared times x, because I can square root the x squared. Square root and squared just cancel out, leaving an x. And this does not square root, so we'll have to leave it as the square root of x. That is my final answer. X times the square root of x. I know that's a little weird. Let's try another one like that. What about the square root of x to the 5th? Again, with these odd exponents, it's not going to be possible to come up with something times itself to give you that. So instead, let's think about how we could break up x to the 5th into something that we could square root. This is 5 x's here. One way to do it would be to split it into x to the 4th times an extra x, because 4 plus 1 gives you the 5, so that's x to the 5th, just broken up. The reason I went with x to the 4th is because 4 is something that divides by 2, basically. The square root of x to the 4th is x squared. We already talked about that. Again, this little square root of x won't simplify. We can just leave it as it is, and that would be my final answer. Another way you could have done this one is think about splitting it into x squareds, because we know we can square root x squared. So how many x squareds could we fit into x to the 5th? I could do 1, 2, now I'm up to 4 x's, and I'll need 1 more to make 5. I haven't square rooted anything yet, so I need square root signs. Square root and squared cancel, and just leaves x. And this square root and squared cancel, and leaves an x. And this square root of x is just going to have to say square root of x. Notice this gives me the same thing that I got before, because x times x is x squared times the square root of x. So however you want to do that, there are often many ways to do it. We'll do a couple more examples in the next video.